Oh, get ready, people. Here it comes. Here it comes. It's area. Area of polygons. Yes, yes, it's time to reach for your hazmat suits there. Put on your protective gear. All right, let's get into this here. So, area we have definitely come across before, and specifically here is the definition. So, area is the number of square units it takes to completely fill a two-dimensional shape. So, with our rectangle, which we've seen before, is we can simply count a 1, a 2, a 3, a 4, a 5, a 6, a 7, 8. Yeah, so the area would end up being 8 here. And because there's centimeters, we say 8 centimeters squared. Now, again, we say squared because it's 8, what? 8, yeah, 8 squares it took the units of measurement. So it's 8 1 by 1 centimeters. So we can do that. The other thing we can realize is it's much faster if we just do a multiplication problem. 1, 2 tall, and then 1, a 2, a 3, a 4 wide. So 2 times 4, that gives us our 8 that we're looking at. So I guess I could have put it right there. Yeah. I'll finish it up, get my labeling there as well. There we go. Okay, so so that's your rectangles. Now your triangles, what we want you to notice here is all a triangle really is it is half of a rectangle. So let's see here. So it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. All right. So it's a 5 by 6. So this rectangle here is 5 by 6. But remember, we only want half of it. I only want this amount. So 5 times 6 gives me my 30. Oh, but wait, I only want half of it, so I'm going to divide it by 2, and there's my 15. We're going to use centimeters squared for all of them. All right, so again, the idea here is all a triangle is half of your rectangle. Now, the only thing we're going to see moving forward here is we can only do this with our right triangles. And look at this triangle. That's not a right triangle here. So, here's what's going to end up happening. We can still deal with our whole rectangle that we're after. Okay. Hopefully you're having a little better time with the straight lines there. All right. But then what we're going to do is we're going to take that rectangle. If we subtract out this particular, I'm going to call this triangle number 1 here. If we subtract out, this triangle, all right, and then we subtract out triangle number 2, subtract out this triangle, what are we left with? Well, you can, hopefully you're having a better time than I am there. You can see you're left with that original triangle that we want. So, if I can subtract out that triangle and then subtract out this triangle, all right, all is going to be good. And what we do want you to notice is do you see how it's a right triangle? Take a look, oh my goodness, there's that right angle. And that's key. All right, so we do need that. So we count how wide it is. It is 3 wide. All right, a 1, a 2, a 3. How tall is it? A 1, a 2, a 3, a 4, a 5, a 6. All right. So this particular triangle, all right, again, if we completed it, we'd have an area of 18. But wait, I only want half of it. So half of 18 is, yeah, it's 9. All right. Let's go to the rectangle. I kind of went backwards there a little bit. Let's go to the rectangle. We know it's 6 tall. It's 1, 2, 3, 4, all right, all the way across. So 6 times 4, so it has an area of 24. And in this last triangle, we can see it's 1 wide to get from there to there. It's 6 tall, so 1 times 6, again, if we make that rectangle that's there, 1 times 6 is 6, but half of 6 is 3. So again, work-wise, all right, if you want to show more of it, that's fine. But I think we can do the mental math that's there. And then we're just going to do our subtraction problem. 24 minus 9 and then minus the 3 that we've got there. So 24 minus 9 is 15. 15 minus 3, and there's our 12. So 12 centimeters squared. Okay, so for example, number 4, what we've got going on here is and we want to scan for. Check this out. Look at this. It's kind of, is it in the middle? I think it is. How about that, guys? Yeah, all right. So one of the things we got to watch for is if it doesn't kind of match up, and I'm not saying it has to be perfection. I mean, that's good enough for there. That's good enough from there. But clearly that's not on one of the grid points. We don't know how far that is. So this problem we can't even do, all right, because we do not have, so there's not enough information. All right. So we do want you thinking like, can we do it? No. We don't know if that's a half, it's a fourth, if it's a quarter, if it's 1/8. All right. 1/3. So those are things we want to watch for. Okay, so up to this point, the technique has been make it a large rectangle and then subtract out what you don't want. Well, you can actually go about this two different ways. You could actually go inside the shape, because look, if I draw on these lines, didn't that make a right triangle? Isn't that a square? Isn't that a right triangle? Yes, so because they are, we can go ahead and find the area of each of them. Now again, the big thing here is that they were right triangles, all right? If they're not right triangles, all right, and that's what we saw above, can we find the area of it? Nope, we can't, all right? Nope. It needs to be a right triangle just to find the area of it. So let's see here. So how wide is it? It's 3. How tall is it? It's 3. Now again, that would be for this entire shape. So 3 times 3 is 9, but I want half of it. Half of 9 is 4.5. I'm going to add on the square. So it's 3, and then 1, 2, 3. 3 by 3. All right, so that's 9. And I'm going to add on this other triangle, which is, again, 1, 2, 3, and then 1, 2, 3. Oh, hey, wait a second. I've seen you before. Yeah, 3 times 3 is 9. Half of 9 is 4.5. So now in this case, we're going to add them all up together because, well, those are the pieces that we need. So you might find it's easier to add these two guys first. 4.5 and 4.5, that's 9. 9 plus 9, hello, 18. Just makes your life a little bit easier. Again, centimeters squared, because we said everything would be centimeters. Okay, so a lot of these we want you to kind of do yourself. We're just going to go through a few of them and then save the other ones for later. So what we do want to notice is, oh my goodness, what a wonderful problem. Why do I like this triangle so much? Why? Go ahead and sing the praises of this triangle. Tell me, why do you like it so much? Uh-huh. Yep. All right. Yep. Yeah, you're right. It's got a right angle. When it's got a right angle, we love it because all we need to do is, let's check our measurements. 1, 2, 3, 4. All right. 1, 2, 3, 4, 5. So if it was that rectangle, 4 by 5 is 20, but I only want half of it. All right. So we should get an area of 10 centimeters squared. Now, again, we only want to have, that's why we divide by 2. Just don't always divide by 2. All right. Sometimes we got to leave it alone. All right. No, don't get upset about it. Okay. And like this guy here. Do we have a right triangle? No, we don't. But if I draw out my rectangle, do you see the right triangle over here? Do you see the right triangle over here? Okay. So now I can find the area of that rectangle, subtract out this triangle, subtract out this triangle, and I'll be left with what's in the middle. That's right there. So let's see here. Let's go. 1, 2, 3, 4, 5, 6, 7. All right. How tall? A 1, a 2, a 3. All right. So 7 times 3. Hey, that rectangle is 21. Okay, now I'm going to deal with this triangle here. How wide is it? A 1, 2. All right, how tall is it? 1, 2, 3. Okay, so if we make it into the rectangle, 2 times 3 is 6. But I only want half of it. So half of 6 is 3. There we go. All right, and for this triangle, let's see, it's 7 by 3. That's what's going to make it. All right, so I already have my rectangle form there. 7 times 3 is 21. Half of 21. Yep. 10.5. All right, so we got a little fraction here, no big deal. 21 minus 3 is 18. 18 minus 10.5 is, yeah, it's 7.5. So it is 7.5 centimeters squared. All right. Look at the example number 3 here. Oh, we should be loving this one here because what shape is it? It's a rectangle. Yeah. So let's see here. 1, 2, 3, 4. All right. 1, a 2, a 3, a 4, a 5, a 6, a 7. Now the big thing here is 7 times 4 is 28. Do I cut it in half? Do I take half of 28 and get 14? No, we don't. Why not? Well, because it's not a triangle. All right. So 7 times 4 gives you 28. That's what your answer is.
That's good.
Yes, that is a good looking answer. Again, only chop it in half when you want a triangle, and more specifically, one of your right triangles that you got. We're going to do question number 4 as your last one here. And the thing about this is you can actually work inside the shape here. Check it out. Ah, look at that. Look at that. Right triangle, and a rectangle. It is good to go, people. So I'm going to do all addition here. So let's see here. I'm a 1, a 2, a 3, a 1, a 2. So the area of that entire rectangle, 3 times 2 is 6, but half of 6 is 3. Let's add on the rectangle. It's a 1, a 2, a 3 by 1. 3 times 1 is 3. And then we're going to add on this last guy, a 1, a 2, a 3, all right, which I've added before, counted up before. And then a 1, a 2, so 3 times 2 is 6. But wait, I only want half of it because it's a triangle. 3. Add them all up there, we should get 9. So we should end up with 9 centimeters squared. All right. If we look at this, if we took this particular triangle, we could actually put it right here. All right, it would fit in perfectly, and then so you'd be left with this, and if you notice what it is, it actually makes a square. It's a 3 by 3 square. 3 times 3 also gives you 9. It works out. So lots of ways of visually doing this, and that's what we are working on, is working with your visual skills. So we're going to stop you right there. Again, there's more that we can definitely do, but we'll take care of that later on. We just want to give what you've got there. So that's it. All right.